Hello, Algebra 2. We are doing an introduction to polynomial functions. Long word, but all it means is we have more curves in our functions now. So you guys first learned a quadratic function. Well, first you had linear. So we had linear, which looks like a line. You guys don't have to write this part down. I'm just talking to you. We're about to write this up formally. But then you had quadratic. And the quadratic function has one curve in it. And all of these are forms of polynomials, all right? Because a polynomial is just when you have several terms and you're adding them together. So for linear, we just had ax plus b. With a quadratic, we had the ax squared plus bx plus c. So now we're going to add on a few more, and you're going to wind up having more curves. Every time that you add another term on, you're going to wind up adding in another curve to your function. So polynomial is a big word that includes a lot of the different functions that we've been talking about, from linear to quadratic to the next four that you're going to learn today, all right? So go ahead and get your notes ready, and we're going to make one big list of all the different polynomials that we're going to be working with. All right. Just to make sure we have some common vocabulary before we start, the general form of a polynomial is starting with one term. So I know this looks a little overwhelming. A sub n just means a coefficient. So for example, this could be f of x equals 3, and then x to the nth power. That could be x to like the 9th. Okay? And then plus, you're going to get the next term, all right? So the next term is going to be, let's say this is 2 and then x to the 8th. The n minus 1 means I'm going to subtract 1 because it's the next term, all right? And then maybe I have 6x to the 7th, and then plus x to the 6th, x to the 5th, dot, 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 dot. And I'm going to go all the way down until I have x to the 0. Because x to the 0 is really just 1, so the very last term is going to be a constant, okay? That's all that's telling me. We always want to have our functions in standard form, where the highest exponent is first. So if you notice, my example has x to the 9th, and that's the biggest exponent, so I put that first, and then all the other ones go down in descending order, okay? So my degree is the highest exponent of a term in a polynomial. All right? So if I take the highest exponent of any term in the polynomial, that is my degree of the polynomial. So the example that I did above was a 9th degree polynomial because the highest exponent was 9. The leading coefficient, think of what a leader is. A leader is right in the front. So my leading coefficient is the coefficient that's in that first term. So if you have a polynomial, when a polynomial is written descending order, which means that your highest exponent is first, then the leading coefficient is the first coefficient. So I'm going to say the LC for leading coefficient, okay? The LC, leading coefficient, is the first coefficient. Need a little bit more space. So in my example, up above, my leading coefficient was 3. That was my leading coefficient. And then roots. You guys have seen this word a few times now. Roots are the same thing as the x-intercepts, or the zeros. They are when f of x is equal to 0. It's when you guys cross the x-axis. All right? So zeros, roots, we've also called them solutions. So I'll add that word on here as well. So these are the 3 vocab words that go along with polynomials. So now let's take a look at the different polynomials that you guys are going to work with. All right, standard form of an equation of a polynomial is always with the highest degree first, and then you go down from there, okay? And we are going to take f of x equals a. So for example, this might be f of x equals, if a is just a number, then I might choose 5, okay? This is a constant function. It is a horizontal line, and there is no x. So this actually would have an x value exponent as 0. So this actually has a degree of 0. All right? There's no x. It's just y equals 5. F of x equals 5. So my x is actually just 1, which makes my degree 0. Okay? We are going to wind up graphing all these together. So we're going to grab, if you have a graphing calculator, you can try to substitute numbers for A, B, C, D, and E, and F. As we go through these, you'll get all those letters, and then you can have an idea of what we're going to do in class next time. But this is just so you guys have a little bit of an information before you go into class. When you guys have AX plus B, for example, that would be something like, if I pick any numbers for A and B, that might be like 2x plus 3. Okay? So that gives me a line. And this would be a linear function. Remember, we have no squares. The x is not squared yet, so this is just linear. And my exponent is 1. So that is my degree. My degree is 1 because that's the highest exponent on any of my variables. Okay? All right. ax squared plus bx plus c. All right, so for example, in my calculator, I might graph 2x squared plus 5x minus 1. All right, this is a quadratic. You guys know this one. We've used this one several times. So we're going to do quadratic, and that has a degree of 2 because 2 is the highest exponent on my x, on my variable. Again, you can do the same thing for this one. Pick any numbers that you want for A, B, C, and D. And if you graph it in your calculator, you'll notice that the picture we get starts to look a little bit more wavy. It starts to look a little something like this. There's a curve in it, okay? The new word that we're going to introduce is a cubic because the degree, the highest exponent, is a 3. So it is a third degree polynomial, which adds another curve onto my picture. The next example starts with a 4th degree. It is a 4 as an exponent. So this turns this into a quartic. Think about the prefixes you guys know definitions for from English. Quart usually means 4, just like a quarter. There are 4 quarters in a dollar, right? So this is a 4th degree polynomial. And this adds another curve onto your graph. So instead of having 1, 2, 3 curves now, it's starting to make it even curvier as you go through. And then last but not least, when you have a degree of 5, this is the highest that we're going to go, okay? The highest we're going to go is a 5, and this is called a quintic. And a quintic has a degree of 5, and that again adds another curve onto your picture, onto your graph. So now instead of just going up once, down once, up again, and then we're going to go up one more time, okay? Now, depending on what numbers you guys choose for A, B, C, D, E, and F is going to make this graph either stretch or move it to the left or move it to the right, or maybe it'll reflect. So we've talked about different changes to parent graphs. So this is just an example of what a basic polynomial would look like to the 2nd, 3rd, 4th, and 5th degree. But they're going to change slightly depending on what numbers you choose as the A, B, C's, D's, E's, and F's. So let's do a little practice with this. We want to be able to recognize parent functions. So let's think, for example, if I have a graph, and let's say my graph is down here, okay? Even though it's not the parent function because it doesn't go through 0, 0, I know that it is linear because it doesn't have any curves, right? It has a y-intercept and it has a slope. So I know that the parent is a linear function, which is y equals x. Okay? I also know that, let's see, domain and range are going to be negative to positive infinity. And I also know that my intercepts, I have an x-intercept on the x-axis. I have a y-intercept on the y-axis. I know that my end behavior is down and then up. So my end behavior is as x goes to negative infinity. So when I look to the left, this direction, right, my y value is going down. So my f of x is going to negative infinity. And I also know that as x goes to positive infinity, so as I go to the right, this direction, my f of x, my y value, is going to positive infinity as well. And then the last thing that I know, because we've been doing this for every graph that we've learned this year, is the increasing and decreasing intervals. For this graph, I am only increasing because I never change direction and go down or up, okay? So for this one, I'm increasing all the way from negative infinity to positive infinity, and decreasing never happens. So NA, not applicable. Let's try this with one more function. Okay, I'm going to add one more on. Example 2. What would happen now that we have these new graphs? I am going to put a function like this on my paper, okay? I need to think as if I'm a little man who is walking along this function from the left side, so here I am, and I walk in this way, along the path. How many times do I change my direction, okay? First I'm increasing, then I kind of decrease. So first I'm going up, then I kind of come down, and then I go up again, and then I stay going up. Okay, so I went up and down, so there's one change right here. And then I change from going down to up, so there's another change right there. So I change my direction twice. So since I changed my direction twice, let's look back at our list. Which graph sort of looks like that, where I change direction 2 times? Okay. If I look here at the cubic, this one is what sort of looks like my path. I'm going up and then I change. I go down and then I change and then I stay. So I have 2 changes in direction. So the parent graph is a cubic function. Okay? And my function for a cubic, my parent graph, is if I take all those a's and b's and c's and d's away, all I have left is x to the 3rd. Okay? So x cubed is the most basic parent function. But remember, every parent function is on 0, 0. This one is not on 0, 0. That's okay. It just means that it's moved a bit away from the parent function. So my parent function is just x cubed, but this one has been translated a little bit, and that's fine. All we want to know is where it comes from. So it has the same characteristics as the cubic. Based on this picture, I can now find the domain, range, and behavior, just like we've been doing throughout this year. So when you guys come to class next time, we are going to be practicing doing the domain, range, and behavior, and checking on parent graphs to see if we can match them up and get a little bit more familiar with polynomials. See you guys tomorrow.